Welcome to this explainer. Okay, let's jump right into this. Have you ever watched an Olympic gymnast execute a truly flawless routine? I mean, really watch them? Every flip, every twist, every single landing is calculated, precise, and executed with absolute perfect form. There is literally no wasted movement. Every action they take serves a very distinct purpose to maximize that final score. Well, listen, achieving an A-star in Cambridge mathematics requires exactly that same level of perfect form. Whether you are tackling syllabus 0580, 0606, 4024, 4037, 4040, 9231, or our main focus today, syllabus 9709, the principle remains exactly the same. Today, we are looking at a topic where the difference between a B and an A-star almost always comes down to your execution. We're talking about topic 4.3, momentum, specifically linear momentum where P equals mv. We are going to treat your exam paper like that gymnastics mat. Every sentence, every equation has to be a graceful landing. I'm going to show you exactly what senior examiners are looking for, drawing directly from principal examiner reports, to transform your approach from basic, clunky memorization into A-star analytical mastery.
Here is our roadmap for today's masterclass. We'll start with the challenge, then uncover the core concepts, map out a procedural framework, test it all out in an interactive workshop, and finally, lock in the final system. Let's get to it.
All right, here is our baseline, linear momentum. The equation itself is elegantly simple, right? P equals mv. Momentum equals mass times velocity. But do not let that simplicity fool you for a second. In the Cambridge syllabus, this equation is not just a basic formula to be blindly plugged into a calculator. No way. It is the fundamental, baseline principle of systematic analysis. It's a vector quantity, which means direction is absolutely just as critical as magnitude. When examiners test you on 4.3 momentum, they aren't just testing your ability to multiply two numbers together. Anyone can do that. They are testing your entire conceptual framework. They are looking for logical, structured reasoning and evidence-based analysis when particles collide or separate.
To really illustrate why perfect form is necessary, let's look at two hypothetical students taking on a complex past paper question. On the left side here, we have Alex. Now, Alex's approach relies entirely on superficial breadth. When faced with a tricky momentum question, Alex totally panics and just writes down every raw mathematical fact they can possibly remember. Conservation of momentum, kinetic energy formulas, Newton's laws. It's just a total raw fact overload with absolutely zero structured analysis. It's messy, it's disorganized, and it doesn't answer the prompt. Now, on the right, we have Sam. Sam's approach is rushed execution. Sam actually knows the math but completely ignores the command words in the prompt. If the question explicitly says, show that the velocity is 5 meters per second, Sam just scribbles down v equals 5 without showing the systematic step-by-step working. What's the result? Both of these students are losing massive points. They are performing the routine without the form.
And this brilliantly illustrates the core difference between a standard candidate and a top-tier candidate. The Cambridge Assessment Framework actively prioritizes analytical depth over superficial breadth. Let me repeat that because it is literally the most important shift in mindset you can make today. Academic benchmarks for 4.3 momentum require logical, structured reasoning. An examiner would much rather see a concise, deeply analyzed response that tracks mass, velocity, and directional vectors perfectly rather than a full page of scattered, panicked equations. Your goal isn't to show off how much math you generally know. It's to apply the precise analytical depth required for the highly specific context of the question in front of you.
Let's move right into Section 2, Core Concepts and the Strategy Reveal. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSC to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so the syllabus clearly emphasizes that assessment objectives for 4.3 momentum target three very distinct cognitive domains. First up, knowledge and understanding. Do you know P equals mv, and do you actually understand that it's a vector? Second, application. Can you take that base knowledge and apply it to an unfamiliar context, like, say, two railway cars coupling together on a track? Forward, and honestly most crucially, analysis. Can you systematically break down the before and after states of a complex collision? To consistently hit all three of these domains, top students use a highly structured framework. Think of the Peel framework: point, evidence, explanation, link. Make your point about the physical law, provide the evidence from the data provided, explain the mathematical working step by step, and link it back to the specific command word asked in the question. So, you might be wondering, what does this all mean for your actual score? The crucial question is this: how do top-performing students secure the method mark? If you've ever dug into a Cambridge mark scheme, You've definitely seen M1 or M2 scattered throughout the pages. These are method marks, and guys, they are the absolute golden tickets of the Cambridge Mathematics syllabus. Top-performing students know a secret. Getting the final numerical answer correct is really only half the battle. They secure that golden method mark by making their cognitive process totally visible to the examiner on the page.
This brings us to Section 3, the transformation. We are moving from theory into execution with a 5-step procedural framework. Systematic processing within 4.3 Momentum always follows this strict, standardized 5-step sequence. Step 1, identify key elements. You need to extract the masses, the initial velocities, and vitally, establish your positive direction right out of the gate. Step 2, apply relevant principles. Don't just do the math. Explicitly state, by the principle of conservational momentum, let them know you know. Step 3, execute analysis with clear working. Write the core algebraic equation clearly before you start plugging in a bunch of numbers. Step 4, verify results. Take a breath and ask yourself, does this final velocity actually make physical sense based on the masses involved? And finally, Step 5, present in appropriate format. Use the correct significant figures, state your units, and explicitly clarify the direction. This sequence right here, it's your ultimate safety net.
Seriously, let this sink in for a moment. The method mark strategy dictates that marks are rewarded for the process itself. Clear working and appropriate terminology physically demonstrate to the examiner that you have a connected, conceptual understanding. Think about it. If you make a minor, silly arithmetic error at the very end, but your systematic process on the page is flawless, the examiner can still award you the vast majority of the marks for that question. That systematic execution protects your grade from simple calculation mistakes. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's put this into practice and move to Section 4, Interactive Workshop and Data Scan.
I want you to look at the screen and perform a really quick data scan of the table we're looking at right now. In 4.3 Momentum, your data interpretation skills are absolutely critical. You have to be able to extract values rapidly and accurately from texts and tables. Notice the mass differences between particle A and particle B here? Now really focus on the velocity vectors. One is positive, one is negative. If you rush through this, like our friend Sam from earlier, and ignore that tiny negative sign which indicates opposite direction, your entire calculation will totally collapse. This is exactly where you apply Step 1 of our framework. Identify key elements and explicitly note the directional vectors before you write down a single equation.
Now, what's really fascinating is that when we dive deep into the Cambridge Principal Examiner reports, which is basically the ultimate source of truth for what goes wrong in these exam halls, we find that candidates consistently fall into the exact same traps, year after year. In fact, examiners have highlighted exactly 3 major recurring mistakes in the momentum topic.
So what are they? Here are the top 3 mistakes pulled directly from the examiner's desk. Number 1, using the wrong approach for the context. For instance, a classic mistake is trying to apply the conservation of kinetic energy in an inelastic collision where only momentum is actually conserved. Number 2, forgetting format and presentation checks. This means dropping your negative signs halfway through, forgetting units like kilograms, meters per second, or just totally ignoring the required significant figures. And number 3, answers lacking specific context. If the question asks about 2 ice skaters colliding and your final circled answer is just v equals -2, you haven't linked it back. You need to actually say, the skater moves at 2 meters per second in the opposite direction. And this leads us to a massive, flashing red light warning directly from the examiners themselves. I quote, "Candidates consistently confuse key terminology. Always define terms before using them in extended responses. Practical application in 4.3 Momentum means acting like a professional mathematician. You absolutely must use appropriate terminology. Do not just assume the examiner knows what you magically mean by u and v if you have multiple particles moving around. Define your variables. Literally write down, let v subscript a be the final velocity of particle A. This level of absolute clarity eliminates all confusion and completely secures your method marks." Which brings us to Section 5, the final system and evaluative thinking. According to the syllabus, the higher-order assessment objectives demand the evaluation of alternatives and justified recommendations. So if you want to elevate your grade from a solid B to an undeniable A star, you need to master these 3 skills. First, question assumptions. In a lot of momentum problems, we assume no external forces are acting on the system. You need to be aware of that assumption. Second, consider different perspectives. For example, analyzing the system as a whole versus isolating a single particle to find an impulse. Third, justify your decisions with hard evidence. If you claim an object rebounds, your mathematical evidence, like a change in the sign of the velocity vector, must clearly and explicitly justify that claim. You have to identify limitations and understand exactly how they affect your final conclusions.
Let's look at the ultimate side-by-side comparison to bring this all home. A standard response operates purely at the descriptive level. It just says momentum before equals momentum after, so 5 times 2 equals 5 times v, v is 2. It's bare bones. Sure, it might get the final answer mark, but it leaves all those precious method marks highly vulnerable if anything goes wrong. Now, look at the top-scoring response. It operates at the analytical and evaluative level. It begins by decoding the command word. It explicitly states the principle used, defines the positive direction, shows the full algebraic substitution step by step, calculates the result, and finally, provide the contextual sentence with the correct units and the vector direction. A top student performs this exact routine flawlessly every single time.
The truly beautiful thing about this systematic approach is that it is entirely reproducible. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCS to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCS and click that bell. Don't let another exam pass you by.
So, as we wrap up this explainer, I want you to take a second and reflect on your own personal exam strategy. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing that perfect form, systematically apply the framework, and I'll see you next time.